Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about power from different time zone. So let's dive deep into it. So what exactly is the problem? Well, problem is that renewable energy is cheap. That's an actual fact from 2015. So it's cheap, but it does not have high availability. Meaning whenever you are building a big ass power plant, you generally have to design it with the government to offer up a reliable uptime. What does that mean? That simply means if you can put, let's say, making a 800 megawatt coal power plant and you are like, hey, we're gonna make one 800 megawatt generator and turbine system, the government will be like, bro, no, like you have to divide it up to at least two. So the idea is always the same, that you must have redundancy, as in of course you have to shut it down for maintenance. So if you have one power plant that has multiple units, so to say, so like they will turn off the one, maintain it, put it online, then turn off the second one, and then do it this way. This will not only give them time to actually do maintenance without causing too much destruction of the grid, so and too much overloading, because be mindful, when you are shutting down the power, others have to ramp it up. So this is why of high availability matters, be it coal power plant, nuclear power plant, hydro dams. High availability matters a lot. Why? Because again, we consume power 24/7. Of course, you zoom out a bit, you collaborate all the data, you may find there is a pattern, but a grid operator cannot rely on that. Of course, they hope for that, they study it, predict it, but the grid has to be built in such a way that no matter what happens, it can handle it. Of course, to its max capacity, meaning you could be like, hey, late evening, there is not that much electrical demand, people are like coming out, but let's say there's an India-Pakistan match at that time in Indian stadium, yeah, power consumption. So grid has to be designed to that way. It's like, I got this. So cheap becomes useless if it's missing when you need it. For example, let's say you are running a, let's say, hospital. Everything is fine, everything is dandy, but at night, nope. You're running on solar at night, it's like, nope. So that's why reliability matters so much. You may be like, hey, if from 2015 solar and wind has become cheaper, then why don't we have only those things? That's the primary reason. They do not have uptime. Their reliability is low. So, and all renewables suffers from that, including hydro also. So that creates a very serious paradox. Even though this technology is cheaper, we are not adopting them as quickly as we can adopt them, simply because availability. So that's the problem. So what's the solution? Well, the solution is you gotta zoom out a bit. Basically, if you're looking from inside a basically country, you gotta zoom out. You gotta go places. You gotta zoom out. So if you zoom out, then you realize something factual, which is 50% of the planet, no matter which time, which date, whichever weather you want to talk about, will always have sun, and it's 24/7 into 365 year round. Do not discuss about that. Like, that's absolute. So if you have three power plants at 120-degree angles from equator point of view, polar point of view, you will always have sunlight. And if you have like four of them, you will have sunlight in two of them, and one would be working at half capacity all the time. So that's factual reality. So this idea of like sun, what will do at night, spread it out, then you don't even have to worry about it. And some countries, like for example USA, they could take care of a lot in themselves. If they interconnect their whole nation and take care of the solar, they could literally have much longer uptime. Why? Again, the multiple time zones they cover on their self. China, they could be almost 4 time zones. Russia, they'll be like, bro, we good. They just have cheap oil, so they don't have to worry about it, but they could do a lot because, again, so much land area is there. So, and what about wind? Wind also has the same thing. There is never going to be a time on the planet Earth where wind is not blowing. It just may be blowing harder or slower, or maybe in different places, but it will always, as long as the planet is spinning, as long as the outside vacuum of the space is cold, as long as sun is hot, we have this. We got this. Like, don't worry about it. We got this. So it's always, and with better satellite data that we have right now, we can actually predict how it's going to change, and we are surprisingly good with it. Like, really scary how creepy good we are. As in, like, go to German wind farms and they're like, this is the output. You're like, dude, it's a wind farm. How you have its output in the future? We know they're good. So reality is, wind and solar, if we can connect different time zones specifically, problem sorted. That's the whole point. So what's the other benefit if you actually did this? Well, the energy storage requirement. Everybody talks about energy storage. Well, yes, but here's the benefit of that. Can we store that kind of energy that we need to run a nation? Yes, there are technology known as ancient technology of 1930s of grid. pumped hydro or closed loop pumped hydro. It can allow you to easily store gigawatt hour of capacity and gigawatt of power. That's doable. Problem is, yes, it can be done. Yes, it can be made hundreds of places without causing too much destruction. Consequences, it's not free, nor it's cheap. It's like solar panels are free compared to its cost. Of course, it keeps working for 70, 80 years. How do we know? Remember, the last one is built in like 1905, I think the first one was built, and most working plants are at least 30 to 50 years old. So we know it works, it's a known thing. So the amount of energy storage we will need if we have interconnects goes down drastically. Rather than just having energy storage for, like, let's say you're relying on solar energy storage for like two half of the day, you will only need energy storage for one half of the day. So energy storage requirement goes down, and this allows, in principle, if you can connect multiple time zones, have a super grid, so to say, 24/7 cheap power. And that is the first time in humanity that can ever be achieved. The only reason we are not power poor at this point in time, our financial capacity is growing faster than the cost of energy. But it's reaching a stagnation point where people are like, dude, I think inflation is actually going to catch up. So that's a bad thing. If you really want your civilization to grow, you need cheap power. This is the only way where you can have cheap power, and without having the worry about like what the heck Putin is going to do or what the heck Saudi Arabia is going to do. So this is the solution. Okay, that's the physics layer. What about the engineering? Engineering is, well, thankfully we have the technology. The technology is ultra high voltage direct current. Now, why is the ultra there? Well, I have no idea who came up with this or what is the scientific reason for this. But if you cross 800 kV or at 800 kV, it's classified as ultra. I have no idea. It should be at 1000. So if you're like 1000 kV, yeah, now you're ultra, but I don't know why it is. But if you are above 800 kV, then you are at ultra high voltage and then direct current. Why direct current? Well, it has no distance limit, meaning if you send AC to very far distance, as in like the moment you start to cross 200 kilometers or 300 kilometers, yeah, no, power will just disappear. So it's like, no. If you even dream of connecting, like, let's say whole of China, like from one end to another end using AC grid, no. And be mindful, this is not a very, what you call, clear transition where it's like AC goes perfectly till this point and then it drops off. It's not like that. It's more of a line, how far you can send and how much energy loss you will have. DC, again, it also has losses, but it has much lower, and it does not have physical limitation of its range. As in, if you are making an AC cable that is, let's say, 3000 kilometer long, the capacitance coupling from the environment to the conductor because of the switching frequency would be brutal. So all your energy, bye-bye. And that capacitive coupling is extremely brutal when you are talking about something that is buried under the sea. Meaning, if you can send, let's say, 200 kilometer energy quite reliably, cheaply with using AC above land, forget about that if you ever try to do that under the sea. Under the sea, 80 kilometers. So that's why we have to use DC, because DC does not have switching frequency. Once it charges up the capacitance, done. It's like static there. It's not changing it 60 times like a hertz or like 50 times. So no distance limit. So you can actually have a conductor that is 3000 kilometer, 5000 kilometer, 10,000 kilometer. It can be done. 50% less loss. What does that mean? 50% less. If you have 1000 kilometer, be mindful capacity. I'm not talking about capacitance loss. If you have basically 1000 kilometer, how much energy will be just poofed? Well, it's not 1000 kilometer. Generally, it's calculated for 100. So if you have that 1 unit of 100 kilometer, how much energy is poofed? That is 6% in AC grid. How much is poofed if you are using a DC? It's 3%. That's why people say 50% less energy loss. So compared to 6% loss, you only lose 3%. And when we are talking about gigawatts, yeah, that loss matters. Be mindful. That's why we use DC the moment we are talking about long distance, not short distance. Short distance does not make sense. Long distance, it does make sense. And if you ever wondered why the heck USA is not interconnected in itself, I'm talking about the in itself, it just have frequency connections. It does not have like, okay, I can ship gigawatts of power from point A to point B. If they did, California would be so happy right now. So simply because, again, we did not build the country in that way. Same problem with Germany also, whereas like our top end is like GG amounts of wind and solar, and bottom part is like we are starving for energy. How the heck it happens inside a country? Because AC grid. So we need high power converter station. What is high power here? Generally anything that is crossing 1 gigawatt, as in 1000 megawatt. So we are not talking about something chump change. We are not talking about 100, 200, no. We are talking about like gigawatt scale, 2 gigawatt, 3 gigawatt, 8 gigawatt. So big converter station. Thankfully, the technology of it exists. India already has a multiple of them, and one of them is 8 gigawatt. China has the most bonkers one that I have seen so far. That is 12 gigawatt. Not joking. Bonkers amount of power. And then we also have to build long, very long cables. We are talking about very long range. And we have to build boats, because these cables are not something that is pocketable. So we have to build what we classify as cradles, and these cradles are big, and the bigger you make the cable, as in like the fatter. Now you're like, why you have to make it fat? Well, there are two vectors you control, voltage and amps, in order to control how much oomph you can transfer from point A to point B, watts as in. Now, why don't you increase the voltage? Well, you can increase the voltage as much as you want when you're talking about in the air, but in here, if you increase the voltage, let's say the core is designed for 300 kV, the insulator is designed for that stress load. Now, if the core is starting to carry 500 kV volts, the insulator will simply go boom. And be mindful, DC has much brutal requirement on the insulator compared to AC. That's one of the side where the insulator has to be perfect. And if you're talking ultra high voltage, yeah, insulation becomes thick. And if you are making that thick, then you may be like, hey, why not just make the core itself thicker? Because yeah, we are voltage limited, but why would you want to cripple yourself? It's like, yeah, we could have made something, let's say, that is using 20 cubic centimeters, 20 millimeter squared. No, why I'm saying 20 millimeter, 20 centimeter squared, or just add a little bit cost of insulation, we can increase the core from 20 to 30 millimeter, 30 centimeter square. Benefit of that is your amps capacity go exponentially higher. You can have like 10 kilo amp, something bonkers like that. So it generally becomes a point where it's like cable is really thick. Consequence, these cradles are like, bro, I was designed to handle megawatt class cable, not gigawatt class cable. So you have to have very big of that. Boats, a lot of them would be needed. ROVs, these things are not just laid on the sea floor, because we have realized when you have this sort of magnetic oomph, shark starts to make love to it. Sea life really starts to make love to it. And meanwhile, there are other things like anchors, boat anchors, fishing nets. These things can get tracked into this. So they have to use rovers like this. They go there, drench it up, bury the cable. Now, it's not very deep. They're not burying it like 5 meters deep, 6 meter deep from the surface. I'm talking like from the seafloor surface. It's a very mild drenching, but it does help. So, and remember, it can be designed in such a way that you are drenching it very deep, but it does also become a hassle if you ever have to pull up section out to update it as in like maintain it in case of failure or breaks. So it's a balance. We do like to bury it as deep as possible so nothing can harm it, but cost of doing that versus is it actually worth it? So, and all that requires high resolution underwater survey. If you do not have underwater survey, you cannot cross the sea. You can be like, oh, I'm going to send this, but you are directly trying to drench into a mountain ridge underwater. Yeah, this puppy is like, bro, I'm out, bro. So that's the engineering level. Can it be done? Yes. Has it been done? Yes. But it's a big beefy stuff. So what's the limitation? If we can do it, we have been doing it, why don't we just take care of the problem? Well, we don't actually make enough of it. It's one of those things like chicken and egg scenario. Meaning before 2015, if you have talked to anyone where we're going to have so much surplus power in a place using solar, people would have laughed at you. Like, bro, like who is selling you, man? Come on, give me some of that good stuff. People would have laughed at you. 2010, they were like, dude, you need to be checked into some places. But right now it's a thing. So we never had a thought process of that where it's like, what if you are overproducing too much for 3 hours a day? We never thought about that. This is the first time we are thinking about it. So that gets a serious scenario. Basically, our production is just not up to the requirement. Demand has risen. How high is the demand? Well, some projects that are being worked in UK and Australia, they are so huge that there is not enough cable manufacturing capability in the planet that the whole project has shifted from, okay, we're gonna acquire the cable and all that. It's like, no, we have to do surveillance and all that. So many steps, paperwork, bureaucracy will take so much time. In that time, we're gonna build factories that's gonna make the underwater ultra high voltage DC cables ourselves. Like the project itself will make the cable. And they're also going to take care of the boats, because we went for the common boats are designed for barely a gigawatt cable. If you start to open your mouth and like, I want 8 gigawatt, this cradle is like, bro, no, you need much bigger cradle to handle. We went for bending radius also becomes hassle if you have very thick cable. So all those things means you have to build cables, factories yourself, you have to build boats yourself, ROVs that can handle that much cable and drench it. That would not be too difficult. Be mindful, none of these things are too difficult. It is like, oh, we really have to oomph it up. back in the days, it's like how oil pumps used to be like a few oil pumps. There was not enough demand. But once demand, you got hundreds of oil pumps. Same thing we are going through here. And one of the vulnerability that opens up when you are having this sort of system is that you have one point of failure. This happened in European Union, where one of the nation was receiving around 1.2 gigawatts from one link. Everything is awesome, everything is fine, everybody is happy. But oops happened. And be mindful, sometimes oops can be human oops, sometimes it could be natural oops. So let's say if underground fault opens up and it tears your cable apart, what the hell are you gonna do with that? So things can happen, things can go down. And in that case, it was like the converter station caught on fire, so that turned it down. They lost so much capacity and there was not enough spare capacity. So that's a really dangerous thing. So how do we solve it? Well, same way we solve hard drives. You have to have multiple links, meaning a nation should not be like, I have one link and this is only link. No, it has to have 2, 4, 8, this sort of links. And each link has to be at low capacity. It should not be maxed out unless necessary. So you can have a spare capacity, exactly how we design grids. So this is also a requirement. Be mindful, we are talking about outside of nations. And you have to have budget to pay all these contractors. These things are not cheap. Be mindful, the cheapest cable I have found, very cheap cable, like even you could buy it. That's 1 foot for $400, super cheap cable. Do not Google the high gigawatts cable cost. It gave me a heart attack, so don't Google it. And you may be like, okay, the cable is expensive. Nah, man, it's free. What's expensive? The crew that pilots the goddamn boat. That is so expensive right now. And basically the employees that can handle these sort of things properly, they are very few and far in between. So their charges, don't even go. Like people are like, oh, you think cable is expensive? Look into how much we have to pay one day to this thing, per day wise. So you really need some deep pocket to handle this. Now we come to the harshest layers, economics. Economics is directly tied to the politics of here. So you have engineering, physics, engineering, economics. So politics applies the biggest hurdle, so to say. Why have we not done this yet? Is that it requires a leap of faith. You're you're putting a lot of faith. For example, UK is putting a lot of faith into Denmark when they are building the Viking link. Who came up with the name? So that's the whole point. That's the link that is around 1.4 gigawatts and the range is like 767 kilometers. So if both of them, Denmark and UK, goes all out on solar and all out on wind, the total availability slot of the solar will grow up. Total availability of wind will grow exponentially. And be mindful, these are quite close by. There are some other plants that are going to Norway, some other like they are connecting French. And I do not kid you, there is a cable link named Cobra Cable. Who came up with the name? And there is Ireland, East-West. Yeah, that's the cable name, East-West. So these are the interconnects that we have to deal with. Now, this is easy. This sort of area is a European Union bloc. It's kind of easy. But the moment you start to dream big, now you're putting a lot of faith into that other nation's government to honor it. Now, this time, this location is kind of like, it's one block, you know, couple of friends. It's like USA dealing with basically, let's say, Canada. It's like, oh, it can be done. Like, come on, it's doable. It would be like India doing with Bhutan or Nepal. It can be done. But the moment you start to go far out, now you're taking bigger risk. Now, EU can do this and they have been doing it. They were the first one who was like seriously realized this. And after Putin going boom boom, they realized they really need to up the ante. So hundreds of projects have been planned out. Few of them already in greenlit stage and one of them are already under construction. So they have sorted it out. So in next 50 years, they will slowly transform their national grids, basically national grid of France and all that, into good, basically super grid. Now, benefit of super grid, if they interconnect everything, they have enough redundancy, meaning everybody can take care of everybody else. The carbon footprint can almost go down to zero. So they know that. But the moment you want to expand, that reaches some serious problem. Basically, the moment you want to, like, I want solar even at night, you have to go in different time zone. That requires this project, that is 3.6 gigawatt of connection that is connecting to Morocco, if I'm not mistaken, Morocco. Basically, yeah, it's almost going to Africa. So cable length is bonkers. And there is another project that is similar length that is going from Singapore to Australia. I'm not joking. They're literally trying to make love to that far. So the moment you do this sort of thing, EU, it's a mild inconvenience. Doing this, it's a leap of faith. So this is a very big deal. However, there is one ray of hope, is that whenever these sort of links were done, most of them did what we call ROI, as in return on investment, quite quickly. Like quite quickly. It was like, oh, that's it. Like 1 year ROI done. Be mindful, cable could easily have, if built properly, could easily supposed to have lifespan of 20 years. And it's not like after 20 it goes poof. It's just like it may be better to just remove it. And modern cables that we are building now, it's even longer lasting. So 20 years is assorted, and if you can have ROI in, let's say, 7 to 8 years, that's awesome. That's like shut up, take money. So it can be done. And that's the good part. Consequence still expensive. You're talking about like some serious long-term loans a country has to take out to take care of this. And that means it's very disproportionate, meaning people who have rich coffers, so to say, they can take care of it. Others who do not, they'll be stuck burning coal. So that's an issue. So can India do this? Unfortunately, we do not have good couples around us. We have China. We have Pakistan. The only country that itself has no issue is like Russia, but they don't need to because they have cheap oil and gas. So that's the politics of the situation. It's not easy. You have to take a leap of faith on other countries' government that they're gonna be stable, they're gonna keep working, and they're gonna be like honoring the deal for like 20, 30 years. So yeah, that's the issue. So India may require to go, let's say, as far as South Africa, but I do not trust South Africa's government because their corruption makes Indian corruption look like, bro, we don't even have corruption. So that there is some serious political issue. Be mindful, if we could do this, which China was proposing that they're going to build the super link, and can they do it? Yes, absolutely they can do it. And because all of these links are two-way links, meaning energy goes both way, we can literally solve energy crisis today. Like done, go home. Of course, it will take time to build, but that's what I'm saying. Engineering wise sorted, economics wise is sorted. But politics is a very oops thing. And every country that China approached, they were like, no sir, no sir. No, I will have a Viking coming to my shore, but I will not have a Chinese coming to my shore. So this was my presentation on basically interconnecting different time zones. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.